Hello, everyone. And today I am improvising a new stream. It's not the usual advent of Rust. Today I have about 1 hour where I would like to show and oops, technical problems, sorry. So I'm here again. Yeah, I was saying that today I want to show a new library in Rust that I've been working on, and maybe work on the library together for about 1 hour. And Tommaso is here to help me out. He's a lot more experienced than me in Rust, so he has been giving me already a lot of tips, and yeah, that has been super useful. So thank you, Tommaso. I don't know if you want to introduce yourself very, very quickly.
Hi, I'm Tommaso. Actually, I'm not a big expert in Rust, but we try to work. I don't know, to build a better world. Let's try.
Okay, nice. Yeah, so definitely more experience than me anyway, so it's gonna be very useful for sure. And thank you again for being here. So let me share my screen just to start to show you what is the main idea of the library. So basically the library wants to be a library for the Google Maps static API. And if you never use this API, it's actually, the idea is actually very simple. So basically, if you need, let's say, like a screenshot from a map in Google Maps, it's something that you can actually do with just an API. And the API is essentially built in a way that you just form a specific URL with lots of query string parameters, and all these query string parameters will describe exactly the portion of the map that you want to snapshot, if you want to add overlays like markers or other kind of things. And just to show you an example, here, this is the official documentation, and you can essentially build this URL, and you can see that there are a lot of query string parameters, and you are essentially saying to Google, I want a screenshot of more or less centered in Manhattan, and then add 3 custom markers indicating different things that we are going to call S, G, and C. And you can see that all this information is actually packed here in the query string parameter. For instance, we have center, and center is this address, Brooklyn Bridge, New York. Then you can specify other parameters like zoom, size, and then you can add a set of markers. You can see that we have markers multiple times. And every marker is basically one of these pins that you can drop on the map. And at the end of the day, this is literally a static image. So you can, I don't know, download it, use it in an application. I was actually starting to do this little project because I was thinking to build a Twitter bot that will post maps in particular circumstances. And then I ended up in this rabbit hole of how do you create maps? Oh, nice, there is an API, and let's make something in Rust because it seems like an interesting use case to practice a little bit of Rust. So nothing extremely useful. You probably can just use this URL and build it yourself straight away. But since there is a lot of configuration, the idea of the library is that if you really want to use all the more advanced features, maybe it's convenient in a language like Rust that is very strong typed, to have like an helper that allows you to build the URL and make sure that it is correct and you get access to all the options. By the way, we also have Tommaso's cat as a guest, so you might see him or her, I'm not sure.
Him, but
Okay.
also her. But
Okay,
yes,
nice. So 2 special guests. That's very cool. Okay, does it make sense, Tommaso? Do you want to add anything?
no. Actually, the library is a builder that creates this URL with some checks. Hopefully, we need to implement the checks, but actually is a builder for creating this URL.
Exactly, yeah. And I'm gonna be sharing the code in a second, but yeah, effectively the current state of the implementation, which is not 100% complete. There is lots of stuff implemented, but probably many things are still missing. But the idea is that basically we have types for essentially every option that you have to customize the map. For instance, center is going to be a particular type, zoom is going to be a particular type, size of the map, markers, and so on. We also have subtypes, like for instance, you can see here that a marker can have a color, so we can also model colors. And we have locations that can be GPS or addresses. So we are trying to encode all of that stuff in a way that should be more or less idiomatic in Rust. So you instantiate types. Those types are essentially guiding you to provide all the correct parameters. And then you put all these things together. And at the end, you have a URL that you can use. So let's look at the code. And we are in the middle of a refactoring, which we are doing in another branch. So I want to show you the current state of master so that we can explain where we want to go with the refactoring. Oh, by the way, I didn't mention that, but the code is already on GitHub. Let me make sure I have that. I think that's a URL. Yes, so you can check the current state of the project here. I'm gonna try to show it on screen. Right here. And basically, yeah, let's have a look at the code now. So as you can see here, I don't know if this is readable enough. Let's make it a little bit bigger just in case. As you can see here, we have a lot of files, and it's very easy to see that we are trying to model every single concept, let's say, in the library as its own type, its own file, and so on. So the main entry point, of course, is lib-res, where we are including essentially all the other files and exposing all of them. And now the main thing is that, as Tommaso was saying, is that the entry point, let's say to use the library, is that you have a builder, and it's called URL builder, and this builder will accept a number of things. So will allow you to incrementally build the URL by providing all the different options you want to use. Now, there are two pieces of information that are required. So credentials and the size of the map. Everything else is optional. So you can, the simplest map that you can have is a map where you just provide the credentials and the size, and that's it. Or almost. In reality, there are some edge cases. For instance, of course, if you just tell Google, I want a map of a certain size, that's not enough to give you a map. So in reality, you need to provide an additional parameter, which is either a center saying, okay, I want a map centered in this particular point, or I want a map with one or more markers, and Google is going to try to center the map somewhere in between so that all your markers are visible. So this is not something we have been modeling in a particular strict way. Probably there are very idiomatic ways in Rust to model that you have either one parameter or another and make it type safe, but we didn't want to make it too complicated for now. So we will be adding runtime checks when you try to build a URL to make sure that you have either a center or a marker. But right now, both of them are optional, meaning this is an option and this is a vector that can be empty, right? So if you don't provide a value for this and this is empty, we will probably trigger a runtime error because the URL will not really be valid. Anyway, moving on, you can see that all the other parameters are modeled as options, so you can or cannot specify values for them. And what else? There is a base URL. Now, this is essentially the new for the builder, and as you can see, it just needs credentials and size, and then everything else by default is either none or an empty vector. And then you have all the methods for essentially continuing to build the the URL. So this is effectively an implementation of the builder pattern. So you create an instance, and then you keep chaining methods to specify all the different options that you need. And you can see here that every option has its own method. I'm not going to spend too much time, because if we manage to do a little bit of progress, I will want to revisit this, and I'll explain why. But for now, just think that this is an implementation of the builder pattern. If you see all this clone, yes, feel free to say bad things about our code, but we will revisit this. And finally, you have this method, which is the final method you're going to be calling in the chain of the builder pattern, which is called makeURL. And essentially, makeURL is going to look at the current state of the builder object and effectively use all that information to create the final URL. And in fact, you can see that there are a lot of if statements. If this value exists, then use it. And this will be incrementally building the URL, which is returned at the end. Now, before discussing this method in a little bit more detail, I want to show you just an example of how you actually use the library, just to make it a little bit more clear. So let's see if we have a good enough example. I think this one is good. So basically what we can do, here we are building a map that is centered in the Colosseum. Actually, I do have it here. So this is the map that we want to build. Essentially is almost square, I think. And it's centered in the Colosseum, and it has this style where you can see both like the satellite view, but also you can see all the overlays with roads and places of interest and stuff like that. So the idea is that we create a new builder, and you just say URL builder new, you pass your API key, and you pass asides, which are the two, let's say, required parameters. Then we can specify the scale of the map. So how much, if you want, essentially this parameter allows you to say, do you want the sides pixel per pixel to be doubled? Maybe you are displaying this in a retina display, or you just want the standard one, which is scale 1. Then we have center, which is allowing us to specify an address or a GPS location where we want the map to be centered. Zoom, which tells you how much we need to zoom. And here you can specify other constants, for instance, street level, city level, world level, and things like that. Finally, you have format of the image, the type of map, and you can even specify localization options like region and language, so that the tooltips will be translated or localized in that language. And then at the end of the day, you just say map makeURL, and that will give you a string instance that essentially is your URL, and you can just use it to fetch the image. Now, here I have a bunch of helper methods, so that when I write my test, I don't have to be worried about the order of arguments in the query string parameter. This is just going to create a vector, and then it's going to allow me to compare them regarding of the order. So that's basically how you use the library. Tommaso, does it make sense? Do you want to add something?
Scale 2 streets give a hybrid. Are the constants inside the library?
Yes, actually, that's a very good question. So these are let's say these are predefined constants for you. So if we go, for instance, I think it's scale, that will be easy to see. You have essentially scale only has two options. It's either 1 or 2. And in order to essentially make it very strongly typed, that you cannot just pass, for instance, 3 as a random value, the idea was to use a type. And then this type, since it's a very simple type, I am pre-allocating 2 instances, the 1 and 2. So you don't need to instantiate it yourself. You can just use the global constant. And I am using this pattern in a bunch of places, like color, here, for instance. Color, it's interesting because color can be either a string for some predefined values, like I don't know, black, brown, green, purple, and so on. But you can also specify an RGB value. So at the end of the day, it's an enum where you have these values that are essentially predefined for you, or you can create your own custom color by providing these 3 values in the RGB variant of the enum. So for these ones, which I think are the ones you are going to be using most of the time, unless you have very specific need, you already have instances prepared and you can just use them. Now, this might be something we could debate in terms of memory, because of course, all these instances, I think they are generated at runtime, and as soon as you start to use the library, regardless if you use them or not. This is at least my understanding of Rust. Correct me if I'm wrong, Tommaso. So maybe this is a little bit of a trade-off between making the library a little bit more user-friendly, but less memory efficient, basically.
I think if we use const, const is like defined in C, so is not allocated, and replaced instead is replaced everywhere. So is not, if I remember correctly, please.
That could be an interesting thing. So I'm gonna add this to my to-do list, because that might be interesting to explore as an option that maybe gives us both the best of the 2 worlds. So we have a library that is still convenient to use because we have a bunch of things already there for you to use, but at the same time, it's not going to have a big penalty in terms of memory. Well, I don't think it's big, but there is definitely a penalty in terms of allocating unnecessary memory, maybe.
Yes, the difference, if I remember correctly, between static and const is this. Static use the same reference, the same variable. Instead, the const replace the variable, the value at build time. If I remember correctly, but we need to check on internet.
Exactly, yeah. But that's a very good suggestion, definitely worth exploring more. So I think, well, this should give you a good idea of how the library works and what you can do with it. Now, I think I presented the library, right? Or do you think there is something missing? Okay, and now I want to show you, like, before we introduce this point, I want to show you again the code that we were looking at before, which is that make URL method. And then explain what do we want to achieve and how do we want to improve this code. So basically, again, this method is essentially the final method in the chain of methods that we are going to be calling to build a URL. So you create a builder, you provide all the different configuration by calling different methods, and at the very end, you are going to call make URL. So this method is responsible for looking at all of that configuration we have been providing so far and use it to build the actual URL. So that's why it takes a reference to self. So it's looking into its own configuration and returns a string, which is the actual final URL. So the first thing that we do, we start to create a URL instance starting from the base URL, which is that Google Maps base path. And then we add the arguments which we know need to be there all the time, and that's the sides. And we are not adding the API key just yet, just because we are going to add that at the very end. And I'm going to explain also that there is a signature mechanism. But for now, let's just keep in mind that there is, this is the first thing that we do. We add the sides, then we start to look at all the other optional parameters. And then at the very end, we add the API key and we see if we need to add a signature, which I'm going to explain in a second. But basically, how does it work to add optional values, optional configuration values? Do you remember that basically every configuration value is either an optional or a vector? So essentially what we need to do is to check, is this value set? If it is set, we need to append it to the current URL. And an example here is center, which essentially is where do we center the map. If it is set, then we need to add this value. And essentially, we have to do this if let sum to make sure that that optional value has a value. If it has a value, we take the query string parameter from this URL and we append a new pair, which is going to be called sender, and is going to have the specific string representation of that value. So for instance, if this is an address, it's going to become sender equal that specific address in URL encoding. And if you look at another example, for instance, scale, it is pretty much the same code. So if the option scale is set, then again, we take the URL query string parameters and we append a new pair. If we look at format, again, it's the same story. If you look at map type, it's the same story. And you get the idea, right? So this is very repeated code if you want. Probably there is something we can do to remove this repetition and come up with a more elegant and reusable way. One last example, which I think is important to understand, like the final design that we want to achieve, is that the common case is that you have one option and that option might add a new query string parameter. So for instance, zoom equals something, or center equals something, or region equals something else. But there is a special case, which is the markers case, where you can have more than one. You can have 0, 1, 2, 3, and more. And so at this point, we model this as a vector rather than just as an optional. So of course, here we need to iterate over every single value in that vector. And if there is a value, then that's, again, we need to say markers equal something. And for instance, if you have 2 markers, you will see markers equal some value, and then again, markers equal some other value. So this is how Google Maps is modeling the option that allows us to provide multiple markers on the map. So if we start to think how can we generalize this, the idea that we had is basically we could create a trait that defines types that can be converted to values in a query string format, right? So essentially, at that point, we can create a generic vector of these trait objects. So all the objects, let's say, that are query stringable, just to give it a behavior, let's say. So all the objects that are query stringable, at that point, you just do a regular loop there and just say, okay, for all of them, just give me the query string representation of every single object. But remember that some objects, some types, they might create multiple instances in the query string, so multiple key value pairs. So the more generic abstraction, and we are going to see the trait in a second, is that a query stringable type essentially has a method that will return you a vector of key value pairs. So at that point, what we can do is, for every query stringable, take the vector of key value pairs, and these key value pairs are appended to the query string parameter. Does that make sense, Tommaso? Am I explaining it well?
Maybe it's better to looking for the code.
Yeah, you're probably right. So let me check out the other branch, which I think is called refactoring. Okay, so let's look first at the trait that we created. So we created this trait, which is called query stringable, as I was saying, and then a type that implements this trait is basically forced to specify as query params. So essentially convert yourself to a set of query string parameters. And a set of query string parameters is essentially a vector of tuples where you have string. So essentially it's a vector of couple of string values. And the couple is representing what is the name of the query string attribute, what is the value of that query string attribute, and you can generate one or you can generate more of them. Make sense? Okay, so we'll see how to use it in a second. And then we have a bunch of other methods here, well, blanket implementation that we can discuss later on. These are just, again, to make the code more concise and to save us essentially to having to handle special edge cases. This will help us, but we'll get back to this in a second. So let's say that now we have this query stringable and all our attributes. This is something that I don't think we have done 100% yet, but the idea is that for every configuration option, they will be implementing query stringable. And at that point, you just have a vector of things that are query stringable and you just run over them and get their as query params. And this is something that I think we started to do in lib. Now, this is the new version of the implementation. So now this is the same as before. We create the URL, and then what we do is we have now a generic instance of the object that allows us to append new query string parameters to this URL. And at this point, we create a vector of what we call essentially parts. What are the different parts that will be added to this query string? And as you can see here, this is a vector of trait objects that are query stringable. So at this point, we are mixing types that are potentially different, but they all implement this trait called query stringable. If you have never seen this is something that, if I'm not wrong, is generally referenced as type erasure or dynamic dispatch. I'm going to try to explain what that means. I'm not the most experienced, so maybe I'm going to be using the wrong terminology, but I hope I'm going to be able to explain the idea behind this. But the point is that basically Rust is going to create a vector where we have pointers to, well, there is a lot of going on behind the scene there. I'm going to try to simplify, but essentially these pointers, they're going to be pointing to potentially different types. But the one thing that all these types have in common is that they all implement query stringable. And at that point, of course, since we don't really know exactly what is the type of every single item, the only thing that we can do with those items is to call the methods that are available in this trait. So this is also why sometimes it's called type erasure, because at that point, it doesn't matter anymore what is the original type of every single item. You can only use the things that are in common, which are defined by this trait boundary. So we can only call that method, I think it's called asQueryParams. So this is the only thing we can call from the objects, on the object in this vector. Make sense? What do you think, Thomas? Is it clear enough?
We iterate over all configuration, call that method, and append the return values into pairs. So this is what
exactly. Yeah.
This is what we are going to do.
Exactly. So now that we define this, let's say, generic collector for all our options, and we explain how Rust manages that, essentially, yes, we just iterate over it. We do a flat map. We take all the... do you remember here that we saw that basically this returns a vector where every item is a tuple with two strings? So this is literally a key value type of association. So here what we do is for every single item in this vector, we are getting one or more key value pairs, and flat map basically allows us to put them all at the same level. So it doesn't really matter anymore if one element is generating one key value pair and another element is generating two. At that point, all the key value pairs will be at the same level. And at that point, the only thing that we have to do is for every single key value pair that we produce this way, we have to append it to the query string part of the URL. So we use pairs, append pair, and then we take key, which is the first item in the tuple, and then value, which is the second item in the tuple, and do all of that. And at that point, what are we doing? Yes, I think this is just leftover code that we didn't clean up yet. So,
yes, because we implement this trait only for center and markers, if I remember correctly.
I think so, yes, because here we are only using center and markers.
Exactly.
Yes.
Remember that center and markers are not query stringable. Center is an option of a query stringable, and markers is a vector of query stringable. So this is the point. We discover a nice feature of Rust that you can implement your traits for options and for vector. Maybe for base types, maybe. I don't know, but this works. This works. So if you have an option of T and that T implements query stringable, so option of T implements query stringable. This is a nice feature because you can provide a lot of I don't know how to say collection of base type, for example, option, result, vec, set, blah blah blah, and so on, based on your trait. So this is nice.
Yeah, essentially what like the convenience, I think, is that if we didn't have this feature, if we couldn't implement this, then in our code, this will get a little bit uglier, because here we will need to check something like, okay, if this is an option, well, we will need to make it an option and then unwrap it, or if it's a vector, figure out how to deal with the vector. Instead, so sorry, not here, where we create the sequence of query stringable, we will need to unwrap all the optional ones manually, or if there was a vector, we will need to essentially go over the vector, take all the query stringable one by one and push them in this vector here. And that will be a lot more manual work here just to get a collection of things that are query stringable. And the interesting thing here is that we are saying if an item is query stringable, also an optional of that item is query stringable, or a vector containing items of that type is also query stringable. And we implemented already the default logic. So if you call query stringable in an option of a query stringable, basically, what's going to happen is that this convenience method is going to unwrap it for you and then give you either an empty vector. So if it was none, essentially we don't have any value to add to the query string. If it was something, then we have one key value pair to add to the query string, which is going to be given from that specific implementation of T. So yeah, this is maybe a little bit confusing because essentially we have generics and we are using wrapper types over these generics, wrapper or collection types. So for instance, option T is, since T, we only know that it's query stringable, this is the only method we can actually use, but it's enough for our implementation because we just want to unwrap the option and then call this method if this is some value. If it's not some value, we just return an empty array because that means, again, we don't have any key value pair to add to the URL. And this is very similar. This is the idea that you have a vector of query stringable. And the use case for this was the markers, because as we said already, you can have 0 markers, 1 marker, more markers. And every time you want to add a marker, you just say again in the URL, markers equal something, then again, markers equal something else. So we modeled this as a vector, but of course, we don't want to deal with the complexity of again, extrapolating all these items from an array just to put them in another array, right? So here what we are doing is saying, if you have a vector of query stringable and you want to get its own asQuery params representation, essentially just do a flat map and call asQuery params for every single item. And then you just collect all of that, and that will be a vector of key value pairs. I don't know if I'm explaining well enough. What do you think, Thomas?
For me, yes, it's almost clear.
Okay, cool. Just to reiterate one more time, at this point here, what we are doing is center and markers. Center is an option because you might be centering or not in a certain point. We saw that, right? And you can see here also the type int is option of location. And markers is a vector of stuff. Don't worry too much, but this stuff is query stringable as much as here location is query stringable as well. So we created a vector of an option query stringable and a vector query stringable. So here we are essentially using both these two implementations. And this is why for now we all implemented these two, because we wanted to test if that specific implementation did work as expected.
Funny stuff. This is not a direct option of center and vector of markers. It's a reference of. Because is a reference of options of
Fair
center.
enough.
And inside in Rust is a similar tricky with trait. So if options of T and T implements something, also a reference of option implements that. Is a nice stuff.
Yeah, so you don't have to write extra code to handle both instances and references to instances of specific types.
Yes.
Okay, cool. So what can we do next? Now the idea, if I remember correctly, is to continue coding all the other options. For instance, here we have size, and size is something that we didn't make query stringable yet. So
I don't remember if center and markers is well implemented actually.
Let's actually, good point. Let's check again here. I think so. Center? Yeah, so center is already implemented, and basically what we are doing is, okay, here there is a little bit of abstraction as well that is worth mentioning. So there is a generic concept of allocation, and location, let's have a look at the library. Location essentially can be two different things. Either an address, so in text form, like, I don't know, streets 22 Brooklyn, something like that. Or you can specify latitude and longitude as pairs, and that will give you a point in the map. So essentially, a location is a point in the map, and you can express it in two different ways. So that's why we modeled this as an enum. And this is a generic concept that we can use in different parts of the URL. We can use it when we create a marker, for instance, as one of the components of the marker, or in general to center the map. But of course, depending on how you use it, it will be encoded in the URL in different ways. So location on its own is not query stringable, but the other types that use location will be query stringable. So location here is just modeling this idea that it's either a latitude, longitude, or it's an address, and then you have a bunch of convenience methods to validate that you are creating latitude and longitude correctly. You can use just tuple of floats to easily create a location. You have a bunch of other helper methods. The only thing that is probably interesting here is that at the end of the day, there is a display that gives you the actual string representation that the URL is expecting every time you have a location. But that's just the value. It doesn't give you the key, because the key is very specific from the context. And one of these contexts is center. So when you want to use a location to center the map, that's a very specific application of that location idea for a specific query string parameter. So here what we are doing is calling the toString of that location and then associate that to the center key, essentially, in the query string parameter. And in order to do that, we use another interesting thing in Rust that we discovered last time, which is you can create a type alias for location itself. So initially we were creating like a wrapper type, but then we realized maybe it doesn't make too much sense to wrap something that only contains a location. Maybe we can just alias that location. And that's essentially what we are doing. We are saying that a location can also be called center. But the interesting thing that we discover is that you can add implementation on aliases. And as far as I understand, this implementation is only available if you're using this center type. It's not going to be attached directly to the location type.
Yes.
So this is kind of cool. I'm not really sure what is the internals, if Rust is literally copying location as a type into center and they are totally distinguished types at the end of the day, probably. But the interesting bit is that if we do new implementation on center, we are not changing location. So location is kind of a starting point. And then at that point, we diverge in different types. So that was interesting, and I lost track on where we were going. So we were looking here.
Checking if center and markers is well implemented.
Yeah, so center, I will say yes, right?
Yes.
So essentially we are saying if you have center and you want to query stringify it, at that point, essentially the only thing you need to do is produce a vector of key value pairs, and in reality this vector is only going to contain one key value pair, that the key is going to be center and the value is just going to be the toString value of this type as a location, right? So we are inheriting, in a way, if you pass me the inheritance lingo, we are inheriting the toString from the debug trait that we have implemented in location. So that's how we can call self.toString and actually get a good string representation of this value. Now let's look at the markers one. And markers is a little bit more complicated because marker is a more complex type on its own. So maybe it makes sense to look at this first and show you. Actually, you know what? I want to show the documentation on markers because I think it's easier to visualize all the different options this way. So let's see, where do we have markers? There's, I think, get started. Markers there. Right, so a marker generally has this kind of syntax. This is one marker in the map. You have marker styles, which is basically another string encoded in a certain way. So let's say this is kind of a subtype, if you want, or another type that you have to combine to get a marker. And this describes, for instance, the size of the marker, the color, the label. You can use custom icons. And then you have one or more locations. And location, we already mentioned that, can be either address, like in string format, or a tuple of floats, which are GPS coordinates. And essentially, you can specify one or more of them. So when you say markers, you're essentially saying, I want to define a common style, and then I can give you one or more markers on the map that will implement that style. So for instance, you can say, I want a green icon, and then you can say, okay, but copy that green icon in location 1, location 2, and location 3. So that there is a lot you can do with just markers. So in reality, when we say one marker, is not necessarily one. You can have one or more of a certain style. So that makes it a little bit more complicated. And that's why we have here this type that implements appearance, scale, and location, where locations, as you can see, is an array of locations. So you can repeat that configuration of a marker in multiple places on the map. And appearance, it's also its own type because you can specify a lot of configuration options. And scale as well is its own type because there are rules around the values you can give here. I'm not going to spend too much time here. Just want to show you, for instance, the marker appearance, just to give you an idea of how it looks like. So a marker can be either an icon, so you provide your own PNG or JPG, whatever, with a custom icon, or you can use a style, and a style is essentially a size, a color, and a label. So you saw in the previous example that we had a little tip saying A, B, and C, for instance. A label will be A, B, or C, like one letter word. With that being said, what we wanted to do, because I'm realizing we're not writing too much code and just talking about stuff, is that is marker well implemented? The query stringable bit, is it well implemented? Let's have a look. We have a lot of traits implemented here, and here we have query stringable. So what we are doing is essentially saying a single marker knows how to encode itself into a query string. So our query stringable representation for this type is essentially saying, I'm going to return a vector where the key is markers and the value is the toString representation of that specific marker instance. Make sense, Tommaso?
Yes. Yes. And toString is implemented above, right?
toString is implemented above, I think, with, yes, the display trait. So here we are basically saying, essentially, this looks a little bit like the code we saw for the make URL. So since this is an object that can have multiple values and they are all optional, what is going to do to essentially serialize this object is checking, is there a scale? If there is, let's add it to the representation, to the string, essentially. Then is there an appearance? Let's add it there. Is there a location? Actually, for every single location, let's add them there. And then at the end of the day, you are joining all the different parts with a pipe. So this method is essentially creating all this part here. And then we are just saying, okay, whatever is this value, the key is going to be markers, which is what we do here. Right?
So, test pass.
Let's run the tests for... now here tests are a little bit messy because I have some tests for the specific sub-libraries and tests in the main library. But let's run all the tests with cargo test and let's see if everything is still passing. It is, which is good. So we can probably continue by implementing query stringable in all the other places. For instance, here we have sites, which we are still managing in the old way. Let's implement query stringable. So if we go to sites...
Size is a dedicated type, okay?
It is a dedicated type because it's the combination of a width and a height. Okay. Now, there are also some validation rules, which is something I'm not 100% happy with, the way they are implemented. For instance, I am clamping here. Like if you give a value that is 0 or less than 0, it's going to give you 1. A better approach will be that this method will return a result, and then you need to manage failure.
Can fail.
Yeah, but this is something we can get back when we do this to do better error management, because I'm taking a lot of shortcuts there just to avoid to deal with results and other things for now. So we have a display, and we also have a convenience method that you can just use a tuple of integers to easily instantiate a size type.
Yes.
So now the only thing we want to add is implement query stringable for size impl, and we need to import this. So we import it by use create
use
query stringable.
Quick.
Go ahead.
No, never mind.
I think now we can use this guy, right? Now that we know where it's coming from. Okay, and now what we need to do is check. So we need to return a vector, that's for sure, and we know it's going to be just one key value pair. So basically, we're going to have here the key and here the value. Now, what is the key and what is the value? The key is going to be center string.
Size.
Sorry, you're right, it's size. And then value is going to be self.toString. I think that should work. And if we want to try that out, the easy way we can do that is basically now this guy can go away. And we can just add here self.size. And if we remove this, all the tests should still pass. Let's see if that's the case. Nice. So we replace that repeated line with a more generic approach.
Obviously, if there are some tests that test size,
we should run them as well, right? Who doesn't like that? I assume eventually it's going to start to move this in a new line. So let's see what kind of tests we have inside. Maybe we don't have any. We don't have any.
Not here, but we don't care here.
Mm-hmm.
But inside lib.rs, lib.rs.
We do have something that uses sides, I think, but it's a good concern to check. Because sides is what you pass by default, so we always have a sides.
Okay. Stop. Okay.
So now we can continue here. We have scale, which is literally we need to do the same work. So we need to do use create query stringable, and then we want to implement query stringable for scale. So again, you can see that scale implements display, so we can call toString in it. And we need to do implement query stringable for scale. And give me a helper. Is this one?
Yeah. Yes.
I don't know why it's not.
Good.
Ooh, and it's giving us a lot more noise than what we need. Okay, so here again, we need to return a vector with all the key value pairs. There is going to be only one. It's going to be called, I think, scale. We can double check that. And then self.toString. And in fairness, this value can either be 1 or 2. And again, the only reason why we're adding all this code to manage either 1 or 2 is because now it is strongly typed. You are not going to be able to assign any other value than 1 and 2 for this specific argument. So that should give us more confidence that in an application, when we use this library, we are building correct URLs. We are not going to suddenly break our URLs because we are using a value that is not allowed. So if we go back to lib, in theory, now we can remove all of this. And basically what we can do is just add self.scale. And why doesn't like it? Oh, because it is already a reference, I guess. No. wait, is it called scale? This is now query stringable. And it's saying that it found an enum. So with enums, do we have a problem? Yes, this is an enum, by the way, and it's the first enum type we are working on, and implement query stringable. And here it's basically telling us that it doesn't like an enum of...
Why is an option of reference static and not option of scale? There is a difference between scale and center.
That's a good point. So there is a difference between scale and center because scale can only be 1 or 2 effectively. So we are encoding that information into a type. And this type is literally an enum with 2 variants, S1 and S2, and they are already pre-instantiated for us, if that makes sense.
No. I think during in the builder, which is the member inside the builder that handles.
Yes, good point. So if we go here, we have scale is option of static scale. Yes.
This is the point. So maybe it's better to remove option or adding an option of a reference of T where T implements blah blah blah.
I think that's the better option. So I'm going to try to explain why I use this signature, and this is not necessarily the best approach. Is the one
because you are using static instead const.
Maybe that's the issue, but what I wanted to achieve is, again, convenience for the user. Let's take an example. For instance, here you have scale 2.
Yes.
I didn't want you to have to do something like scale.
No. Yeah.
So it's like literally it's there, it's ready. It's always going to be either scale 1 or scale 2. So the value is already available for you. But this value is a reference. And I think it needs to be static because the original value is created as a static reference. But as you said, maybe if we use a constant, it gets easier. We can try.
Because we have 2 ways. Or moving the scale into const instead of using static and use const. And the second is implements a option of reference of T where T is implements query stringable.
Yeah.
Because now option of reference of T is not, even if T implements query stringable, the option of reference of T is not implement this trait because we didn't say.
Yes, you are totally right. So our query stringable type doesn't have a blanket implementation for essentially an optional of a reference static. So either we do that, that's option 1, or the other option is we check if we can just do this, basically, I think. But at that point, scale is going to be a constant, right? So we just...
maybe should be this.
Yeah, let's try if this is an option, because I think I would like this approach more. I think it's more flexible if we can do that. Probably it's easier also to implement, but let's see. And it's also a point in our to-do list, so maybe we killed 2 birds with 1 stone. So it was scale, the file we wanted to have a look at, scale. And we want to, rather than do scale 1, scale 2, we just do const, right? Is that the case?
Yes, and remove ampersand.
And this is literally this, right?
Something like that.
Ooh, that maybe just works. It's not complaining here. And it's not complaining here. And let's see if all our examples... Okay, here it doesn't like it.
obviously,
because of course the signature is
exactly.
broken. So now we just need scale like this, right? Yes, that's pretty cool. I like it. And then scale, right?
Here is a reference.
It's a reference to its own scale. And this is all good. Let's see the examples if they are good. Scale works. Cool. Let's just run the tests. And
Yes,
if this works,
the difference is the memory allocation. Because with static, he embedded into a static. So you have
in the final binary, there will be already an instance there.
Exactly. Instead here, every time you use that const, he replace with a new instance.
Is it gonna be a new instance or it's...
I don't know because it's an AM.
Actually, no, I think it makes sense what you said. Meaning, let me try to explain this, at least how I understand it. So we have a builder. Initially, this scale is the one we just changed, right? The scale initially is going to be none. Eventually, you can call .scale on the current builder instance, and you pass a value that is going to be consumed, is going to be moved into the struct with the current scale. And at that point, you have that inside your struct, and from that point on, we use it as a reference. So I think it's only going to be that one instance the first time you want to use a scale. Then, of course, if you want to create another map at the same time, you'll create another scale. But I don't think that's really a big deal.
Not at all.
Cool, I like that. So let's actually try to do this refactoring. Probably we'll need to do it also for other ones here. So let's continue with format. So format again, we need to use query stringable, create query stringable, and then implement query stringable for format. Please give me the impl. This time it did it in the right way. So mysteries of Rust Analyzer or Visual Studio Code, I'm not sure which one. Okay, so again, here we need to return a vector of key value pair. It's going to be only one, and it's going to be format, is going to be the value. And the key is going to be, again, self.toString. So this is pretty much the same everywhere. Now, just to give you a little bit more detail, format is basically the image format that you want to produce. And it can be one of these values. So again, just to give you strong types that will automatically validate things for you, you cannot use any value that is different from the ones allowed. Okay, so now if we go back here, we should be able to remove all of this and to add self format. Maybe if I put a comma, it's not going to complain. Now it complains because I think we have the same problem as before.
Yes.
So if we look at format here, this format is an option of static, so let's do the same refactoring. It's going to become a regular format. Here we are going to accept a format which is going to be consumed and added there. And if we go back to here, we need to change all these ones into, essentially, we want to change all of this to be just this, right?
Exactly.
Cool. So all of that should work. Fingers crossed. I think. Let's run the tests. Nice. So we covered another use case. Now let's try to get all these ones done very quickly because it should be a little bit of repetitive work. Map type is another one, which is here. So again, use create query stringable and then implement query stringable for map type. And okay, now it's giving me 2, but I know I have to use this one.
I know my kitchen.
Exactly. Right, so the value here, I think it was map type. Let's double check. Yes, like this, map type to string, and then this is self dot to string. Now, just to give you more context, and here we're going to have the same constant versus static problem. Map type is how do you want to see the map? As a road map, so just simplified view of the roads, or satellite view, or see like the terrain, or hybrid, which is the one we saw in the Colosseum example, where you see both the satellite view, but you also see all the overlay with the streets. So I'm going to do this in advance. We need to remove all these references. This one as well. Oh, here const. Did we change the other one to const? The formats. Yes, we did. Okay, and then in our lib, at this point, we can remove all of this, and we can say self map type. And this is going to complain because, again, it's a static, so we need to change the declaration here. So map type becomes a map type. And where we use the map type, here, this becomes map type. There is still an error somewhere. What is the error?
Not here, below. Maybe in the test.
Oh, yeah, in the tests. Let's see what I'm doing. This can be... Okay. Now, here, I just need to use this, right?
Yes.
Okay, interesting. Yeah, here it's interesting. You know why? Because it can be a little bit confusing to distinguish. Oh, I see why. Okay. So here, basically, I'm instantiating a new one, but I could just use this roadmap constant, right? I think I can just use this or not.
Remove map type.
Oh, yes, because I probably imported it from the root of the crate. Yeah. Okay, that's good. And I think we might have to change it. Yeah, here we didn't have to change it because it was already following that approach, which is the shortcut I wanted to have. So all good. Run the test. Still green. Nice. Now the next one, I hope this is not too boring. The next one is language. Language, which is... Oh, language is just a string, I think.
Yes.
Is it?
You're right.
Okay, that's an interesting one.
With Zoom, do we do last changes with Zoom, and then we have a try to understand how to deal with.
Yes, good point. So let's deal with Zoom, and we leave the two strings as something to discuss later. So Zoom, it will be pretty much same story. By the way, Zoom, you can see there are a lot of values because you have, I think, 21 levels of Zoom. But in reality, you are going to be using some that are aliased, like world, continent, city, streets. So it might be interesting now to see when we switch this to a constant, what's going to happen. Because we also want to keep the aliases, I think. So we want to keep either use the number from 1 to 21, or you just use continent, world, city, which will represent specific numbers.
But there is only way to know it.
Yeah, just do it.
Just do it and
figure it and deal with the pain.
Exactly. We are confident that Rust compiler
is
Good.
our friend.
Exactly.
So
Do
this
his
is a vec
job well.
of zoom to string, and this is going to be self dot to string, and this is literally always the same. You know what? No. I was thinking that maybe we could have done a blanket implementation for everything that is debug, but then you still don't know this one. Like if you could infer this value as well, we might have made it even more magic, but let's not go there.
Actually, we can use macro for doing this.
I never use macro, but that could be interesting in another session.
Next time.
Yeah. Yeah. Another thing I was thinking is that maybe you can have another method like, I don't know, query key, something like that, which will give you essentially the zoom bit. And then we could implement a blanket that is, if it is the bug, it's just going to call the query key to get the key and the other one. But I don't know.
But
Maybe.
you have to implement this trait for all objects.
Yes. Yeah.
Instead, if you are using a macro, you can decorate your struct with this macro, pass the value, zoom, for example, here, and generate this piece of code using the macro.
Yeah, essentially you can say query stringable parenthesis zoom basically as a string,
Exactly.
and then you implement the macro that will generate all of this for you.
Exactly.
But I think I want to add that as a bonus for the future. I don't know if we'll ever get there. Bonus. Use macro to simplify implementation of query stringable. Right, let's try to finish that one. So here, let's see what can we do. So we want to replace all this static with const, right?
Yes.
And then we want to replace.
No, okay. Yes. There is a nice.
Ooh.
Never mind. Never mind.
Oh, you wanted to do the command right thing.
No,
Maybe.
no, never mind. Never. Exact. Yes.
So
Exactly.
let's see if I can figure it out. There. So we remove this. And then
Yes.
there.
Yes. Save.
Now, let me understand this a little bit better. Because I think here we might have a problem of values being moved.
No. The constant doesn't create an instance of that things. It's an alias. It's like a define.
So this one and this one will be essentially two different values. The same logical idea encoded, but inside the application, they will be two individual instances. It's not like before, it was a reference to the same value. Now it's two independent things.
Yes. Before, if you compare the location in memory was the same. The pointer was the same. Instead, there is different.
Yeah, the compiler will replace world with another zoom one.
Every time you are referring to a const, he creates a new variable for you.
Sounds good. Okay, that's I don't mind. It's not like this is literally a U8, so this is not the end of the world. It's probably going to be the same size as a pointer anyway. So, like, it is not changing anything in terms of allocating more or less memory. But I think, yeah, this is just a nicer thing to use. And now if we go back to our lib, what we can do is remove zoom from here and add it in here.
Yes.
Self.zoom, zoom. And now this is going to complain because we need to change the definition. As usual, zoom is not a static anymore, a reference to a static, but it's just a zoom instance. And we'll need to change here as well. Nice. Now I think we did all correctly. There is another error. So I think we are still using it in the old way. Yeah. So here we just need to say zoom 13, which is much cooler. Like, I mean, everything is used consistently. You don't have to remember where to use a reference or not. So that's good. Nice. Okay, now we have, I think, the last thing we're going to do for today, probably, because we are around 1 hour and 15, is, here, if we go back to the library, is how do we deal with these two values, which are just strings for now. Now I'm going to make a note that it could make sense to convert these values into proper types so that we also do all the validation, because of course you cannot pass here any string. You can only pass strings that represents languages and regions. For instance, for Italy, you will have lowercase it and uppercase it, right? Something like that. I'm not 100% sure, but you have a limited set of values you can use that they represent either languages or regions of the world. So it could make sense is to make a type, but it's just a long list of values. So I was a little bit lazy and I wasn't sure it was a great idea to encode all these values straight away. Maybe there is a library. Maybe we can just use a library. Maybe it's worth checking. The alternative is, if we don't want to do a type or use a library, we could implement like aliases, I guess.
Exactly. I think
Or like
the
wrapper
same.
types.
Not a wrapper, but an alias.
Yeah, an alias, and then we implement query stringable for that alias.
Yes, we should implement two new types as alias, language and region, and implement this trait for those.
Okay, I think we can do that, but I'm curious to see if there is a library first, because maybe if there is, I don't even know how to search for it, to be honest, but let's try to see if there is something like, I don't know, language, code. I bet maybe that's exactly what we want. Isolang. Let's see what they do. So let's see this example. So they say isolang language, and you have DE, and that will give you a specific. It can fail, yes, and then it gives you a type that implements to name.
Yes, but you have to know the SPA.
Yeah, which right now you have to know it anyway, right? Because you are passing it as a string and there is no check whatsoever. So you could say language, Klingon, I don't know. And then I don't know if Google fails or it just ignores that parameter, but it's not a valid value, I suppose. Right?
Yes, but using this library is not a big deal. It's not exposing
let's see if they do any validation, maybe. Like if they have, or maybe they have a list of constants. There is an enum language. Let's see what that.
No, because enum is different. But maybe inside lives. There, language.spi.
Where is it? Oh yeah, SPA, SWA, SPH. Yeah, so they seem to have a list of languages. We could try to use this for at least for the language. Then we still have the problem of the region. It's interesting in the docs, by the way, that you cannot see. Oh, it's show declaration. Some variants omitted. Okay, but we can go to SRC and see. Beautiful. What's going on? Is it still loading the syntax?
Oh.
Wow, this is such a big file. This is like, I don't know, thousands of lines. I think if my browser is still trying to load. Jesus. This is, yeah, it doesn't even scroll.
A huge
Nice.
file.
Yeah, you have all these beautiful languages. The one thing I don't like is that I hope that you can also use 2 letters code rather than 3, because that's the way that Google expects. So it will be weird for users of the library that now they have to know the 3 letters code to use a 2 letters code.
Go to 7,300 in
7,000.
Yes,
Yeah, I think
the number lives inside the bar.
you know what? Why don't we open this in GitHub, right? Maybe GitHub is a little bit better for visualizing the code. Right. Okay. Here at least there is some code. Let's see what they do.
It's strange because it's not the same.
Yeah, they have these 3 letters. No, I think there was a rendering issue. Maybe the file was so big that the code highlighter was failing or something like that.
Yes, but this file is not so long.
Oh, you're right. Yeah. Maybe there is a macro and the code is expanded in.
No, I don't think so.
Yeah, it's very different. Is there other files?
Maybe is
This
not on
one.
the tag.
This one. No, this one is pretty small.
Maybe master is not the last. Build.rs. He builds at compile time. He reads a table and generates codes.
Which I suppose it makes sense rather than maintaining a file that is like 80,000, whatever it was, lines. Yeah. Okay. I don't know if I want to go into this rabbit hole now, because then we have the same problem for regions, and maybe we don't find an equivalent library. Maybe that's something to add to the to-do list as another bonus. And now we just implement it in a dummy way with a new type.
Yes, without any checks.
Okay, so let's do that, and let's keep it simple for now. We'll commit these changes, and I think we can call it a day for this morning. So how do we implement that? We do a new file, I suppose, and we call it language rs, and we say that type language equal what, string,
Pub.
and it needs to be pub.
Put this in lib.rs.
Oh yeah, that's why it's always complaining. I always forget this step coming from JavaScript. Language goes here, and then language goes here. Right. Okay, now it's up. Thank you for the suggestion. And now what we want to do is use create query stringable, and then implement query stringable for language. And basically this needs to be returning a vec, sorry, again, give me the
implements
thingy. Yeah, and this returns a vec, which, what was the key? Was it language or lang? Let's check it out there. It was
below
language. So language to string. And then in this case, it's literally just self, because that will be the string, right? As oh, we need to clone or not?
Yes, you have to clone because
This is not taking a reference, yeah,
of self. But we want and not consuming, because after the question is after the build.
Mm-hmm.
Yes, after the build, so after you are invoking make URL, the builder is consumed. But this is another, if I remember correctly, is another to-do list.
Yes, we have. It's a broad topic, I suppose, because we can try to apply this mindset in multiple places. But for sure, here, this is one of the points. Basically, the current implementation of the builder, I don't think we mentioned this before, so I want to mention it. But the current implementation of the builder, every time you call an additional method, it creates a copy of the builder and it changes things. So it's kind of an immutable implementation of the builder, which in a way kind of makes sense. I mean, it's easy to use and you don't have to worry too much. On the other hand, it's allocating every single time a copy. So you probably just want to build one instance of a map. In reality, every time you call the method, you are creating a copy. So you end up with multiple instances without even noticing. So maybe that's not, from a memory perspective, that's not the best approach. So we were thinking we can have the best of two worlds if we implement clone. So every time you want to clone, because maybe you want to create multiple instances, you can do that. You manually call clone. But then the default implementation is consuming itself. So you basically, rather than creating a new instance, you consume yourself and return yourself. So it's always the same instance that gets mutated over time. I don't know if I'm describing this correctly, but maybe we'll do another stream on this refactoring. Okay, so
you can put as
good, right?
You can put as a string and not reference of string. So you are forcing to use.
Yeah, here we are forcing string.
No, in the line 3 language, the string is not a reference of string. So during the test, for example, in the test, you passing a reference of string, not a string, if I remember correctly.
Yes, I think I was doing something more generic where you can use both either an str or string. So let's try to use this and let's see if we need to change something.
Okay.
Because I think this is simple enough for now. So let's start by changing the type definition first. So now language is not an S anymore, but is a language, right?
Yes.
Now the language setting is here. It's not an S anymore, but it's a language, if I can type. Okay, and all of that is good. And here now, the only thing we need to do is add self.language and then remove language from here. And I think our tests will need to be revisited. Yeah,
yes.
I think there is an error here. Okay, because now it's not just an str, but we need to do to string. Or will that work if we just do this?
Yes, to string. Because language is a string and not a reference of string of str. Sorry. If you want to pass IT as a reference string, reference of str, sorry, the language should be an alias, not a string, but a reference of str.
Can we do that? As I'm just
I
curious
really don't know.
if you can do like this. Is that what you mean?
Yes.
You need to specify a lifetime. What if we do this? Doesn't like it. Yeah, it needs to be probably static. Okay, you can do it with static. Maybe that works.
Dot into. This because self is a reference of str. So
And into will give you. Are you sure?
to own, sorry, to own.
Okay, I was thinking just to put like an asterisk, but that doesn't work either. To own.
To own. No?
Oh, because here wants to return a string. That's the problem. Then you need to also do to string, which it gets very
Okay, you
messy.
remove
So at that point, we can just do to string,
exactly.
right?
Exactly. And this allow you to remove
Here we just
there.
remove that.
Exactly.
Okay, which I like it because I mean, most of the time you want to do this. You don't want to allocate a string and yeah. Fair enough. Okay. So last thing we need to do, let's check the tests now. They should be green. And yes, and now we need to do very quickly the same stuff for region, and then we'll call it a day. So new file, region.rs. Let's add region before. And I'm trying to keep them alphabetical order, at least I know where they are. Okay, now if we go to region, what we want to do is use create query stringable, and then we want to do pub type region, and that's equal to &static str, and then implement query stringable for region, and then help, thanks. And I think that's just region dot to string and self dot to string. Why doesn't like it? Oh, interesting. So I think our understanding of the alias is not correct. Yeah, so this is literally an alias. It's not. So we are implementing this in str basically this way.
No, I don't think so. But maybe because it's a reference of static, maybe it's that problem.
But here it's saying that there is a conflicting implementation for static str.
Yes, but
Let me do one thing. So if we here we comment this one,
exactly,
is that gonna be happy? Yeah. So
so
it is a conflicting implementation. So we need to do a wrapper type, I think.
Yes, and maybe provide an into.
Exactly. Lots of work we didn't anticipate, but I mean, not the end of the world. So type language is essentially becomes struct language, and it becomes this. Can you do a wrapper around a reference? Or we need, you need parentheses.
Exactly.
Okay, so we do that, and of course this is going to be self.0.
Exactly.
And now we want to do implement from static str for query stringable, and that is sorry for language. And now please help me. Yes, is it gonna do the imports for me? Oh, we don't need imports for from, right?
No.
Okay, let's see. So here we need to return an instance of self. So what we want to return is literally new language of
S.
Okay.
I like it.
So now this guy is
The same. Struct.
This guy is the same. So this is going to be struct region of static str 0. And now let's copy paste because I'm lazy. For region. And of course, if I don't call the thing. Okay, cool. Okay. So now if we go to libres, we have a bunch of things to fix because why doesn't like this one?
Yes, because URL. But why?
Also, this one will be region now.
What? Because reference of str is not clonable.
Good point. So we need to implement clone for this one. And also here. Good catch. And now this one is happy because let's keep it this way. And now we'll need to change region here to be region. And that should work. And we can remove this guy here and add region here, self.region. Now the test below should fail. Right, I think we have an error here because this needs to become into, this needs to become into, right?
Oh, good.
And do we have other cases like that? No, that was the only example. I don't know if I am using that somewhere else. Let's run the test. Nice, all green. So let's do a recap and then I think we can close the stream. So I think we completed this one for today. Basically what we did today, we presented this library, which is a work in progress. And again, if you're curious, you can check the source code here. We are creating this essentially builder helper for creating URLs of Google Maps static APIs. And it's still a work in progress, even though there is a 0.01 version published, which kind of works. It gives you something, but it's the very early stage version, so don't use it for now. And we'll be probably doing more streams as we progress with this library. So today, specifically, we learned about dynamic dispatch and type erasures and how to kind of generalize a collection of different types that have a common interface so that we can essentially iterate over this list of different types and use that one interface. And that's basically it. Do you want to add anything, Tommaso, while I commit?
No. We learned that alias types, blah blah blah, work not so fun. But I was surprised that was in conflict. I really surprised.
And maybe one thing that we should add to our to-do is to revisit the other alias type we have. Maybe makes sense to convert that as well to a wrapper type.
Yes, but
If we,
dot into.
yeah, it's like unwrap.
Eh,
But I'm going to add it to the list. Discuss whether it's worth to remove alias types in favor of what do you call wrapper types?
Wrapper types.
Perfect. Okay, so thank you very much. I don't think we had many people today, but nonetheless, if you're watching the stream or the recording on YouTube, thank you very much. Feel free to send questions, comments. If you know Rust better than we do, help us to get better. The reason why we're doing these streams is to have an excuse to play more with Rust and build new things with Rust and maybe learn in the process. So if you are doing the same and you are sharing the same journey, maybe you are learning different things and we can kind of share and compare. So get in touch with us. Or if you are experienced with Rust, even better, we definitely can use more help. So thank you very, very much, everyone. And yeah, Tommaso, do you want to?
Thank you. No. You are saying all stuff. So.
Okay, maybe next time I should let you write some code. Otherwise, you are gonna hate me and it'll be super boring.
Actually, it's not boring. It's funny. It's very, very funny.
Okay, that's great to hear. All right, thanks again for helping me with this for sure.
No, never mind.
All right, bye
Thank you
everyone.
for watching, and bye.